Hello and welcome to our review for section 7.6 on Bayes theorem. Let's get started with what Bayes theorem actually says. So if you were to just look at this statement right here, it might look really intimidating and confusing. So rather than going over exactly what that says, maybe we'll try with a smaller example and maybe that will make a little bit more sense, right? But keep in mind that, all right, so A1, A2, all the way through AN are a partition of a sample space S. What is a partition? We'll look at an example and hopefully that'll make sense. And then E is in the vents, as always. And the probability of E is not 0, and the probability of A1 not 0, probability of A2 not 0. So none of those probabilities can be 0. And we're told that the conditional probability of A sub I given E is given by this formula right here. And we'll talk about that now. Right, so a couple ways maybe to think about how to solve Bayes theorem problems is we have Venn diagrams and we have tree diagrams. So both are used for this kind of stuff. So let's start with the Venn diagram way of looking at this. And actually, in all cases, we'll say, for example, n equals 3, right? So a small enough example. So instead of A1 all the way through AN, think of it as A1, A2, A3. We still have an event E, right? And I is going to be between 1 and 3. So we only have 3 here. So the Venn diagram way of doing this is, all right, so here it is. We have our entire sample space S. And we partition, right? So we subdivide it into these 3 parts right here because n equals 3. So this will be A1, A2, A3, and then our event E is going to be something like this. So E is over here, right? So you can think of this piece over here as A intersect A1, sorry. So A1 intersect E. This would be A2 intersect E. And then this last one right here would be A3 intersect E. And hopefully that makes sense, right? A1 is that whole piece. So of course the piece that's just contained in E would be the intersection, right? So partition, right? A1, A2, and A3 partition the whole space S means that A1, A2, A3 are mutually exclusive. They have nothing in common. And their union, so these both gotta happen, and their union of A1, A2, and A3 is all of S, the entire sample space, right? So that's what it means for A1, A2, and A3 to be a partition of S. They're mutually exclusive and their union is all of S. Okay, so hopefully maybe this very first part over here of Bayes theorem makes sense now that we have this. Okay, what's next? So now let's say we're trying to figure out the probability of A1 given E. Right, so in Bayes theorem statement right there, our I right there is a 1, right? If we want to find probability of A1 given E, or the conditional probability of A1 given E, well, remember from 7.5, this is just the probability of A1 intersect E divided by the probability of E. Right, this is just our formula for conditional probability from the previous section. Okay, let's talk about what the probability of E is. Well, look at this over here. So the probability of E we have, right? So E would be this piece over here plus this piece over here. These are all contained inside E. And then finally, the last piece over here. So if I'm looking for the probability of E, it's really like taking the probability of this over here plus this over here plus this over here. So not like, it's exactly that. All right, so the probability of A1 intersect E over, and the probability of E, you can think of it as the probability of A1 intersect E plus the probability of A2 intersect E plus the probability of A3 intersect E. And now the idea is, once you have this, you can use the product rule that we had from 7.5, right? So the product rule is what is gonna get you from this over here, the probability of A1 intersect E, is gonna be exactly the same thing as the probability of A1 times the probability of E given A1, right? And you do the same thing, and in the end you end up with exactly this formula right here if you just had A1, A2, A3, right? So Bayes theorem, essentially you can figure it out by just doing this Venn diagram and not having to worry about memorizing it, right? So this is just one version, but a more common version, or really the one that we will use most commonly in this class, is the one that Dr. Thunder used in the class on Friday, and the one that I'm about to use now. So instead of using a tree diagram, we're gonna use Venn diagrams, and that's what I would suggest doing on the quiz and on the homework and on the test. So this is, I think, a better way of thinking about this. So let's say n is still equal to 3, so we're still dealing with A1, A2, A3, right? Let's see how this formula comes up. So the way you draw this tree diagram is, all right, so you start with these 3 sets here that partition the whole sample space, and those are gonna be, right, so once you extend the branches of this tree, you will have A1 here, A2 here, A3 here. Of course, the order that I put these in does not matter. I could have put A2, then A3, then A1. It wouldn't matter, right? So, but those are the 3 first, where first branches extend out to those. And then along them, so here you'd put the probability of A1. Here you'd put the probability of A2. Here you'd put the probability of A3. So that's how you do it. Okay. Finally, there's this event E, right? So now the idea is we're gonna have to figure out the probability of A sub I given the event E, but well, these A sub i's are the ones that partition the sample space, so they show up first, and then after them, you get the E, right? But well, it's one possibility is E, and then what's the other possibility? It's whatever is not an E, so E complements, and then you do the same thing for all 3 of them. So E complements, E complements, right? And then along these, you put the probabilities again. So this right here, so remember that this is the probability that the event E occurs given that A1 has occurred, right? So here you'd say this is the probability of E given A1. Here you'd say the probability of E given A2. Here, this is the probability of E given A3, right? And then for these, so this right here would be, and I'll do this in a different color maybe. This right here will be the probability of E complements given A1. Over here, you'd have the probability of E complements given A2. And this is the probability of E complements given A3, right? But this is your tree diagram. There you got it. Okay, cool. So now, how do we use this in order to find, let's say, the probability of A2 given E? So we want to essentially come up with this formula right here when I is equal to 2. And let's see if we can get it from this tree diagram. Okay, So remember again from 7.5, we know that this is equal to the probability of A2 intersect E divided by the probability of E, right? So you set it up that way. And then it's just a matter of chasing these branches, so to speak, right? So if you want to find the probability of A2 intersect E, so you're trying to find the probability of A2 and E, what you do is you go along this branch, right? So A2 and E means A2 and E. And as you go along, you multiply the probabilities. So that's going to be equal to, so at the top you'll have probability of A2 times probability of E given A2. And you can also get this from the multiplication rule. But the tree diagram is pretty clear. You want A2 and you want E. You go along those branches to reach them. And then divide by. So now you want to kind of chase all the branches that get you to E to get the probability of E that's at the bottom over here. Okay, so how do I get to E? I'm going to do this in a different color. That means you either go along this way and then that way, or you go along this way and then that way, or you go along down this way and then that way to get you to E. And so every time you go down a different branch, you add, but as you go along the branch, you multiply. So what I mean is you want to take the probability of A1 times the probability of E given A1, that's that first branch, plus go to the next branch, that's the probability of A2 times probability of E given A2. Oh, running out of space, but right, so this is all in the denominator, plus, and then that last branch is the probability of A3 times the probability of E given A3, right? And then this right here is how you get the probability of A2 given E. And if you look up here to Bayes theorem, the statement of that, it's exactly what you get, right? It's just our n is equal to 3. But that's a way of essentially remembering how to use this formula without ever having to memorize it. So if you can draw the tree diagram, you know the formula, you don't have to worry about memorizing it. Okay, with that said, now let's look at an example from the homework that uses this. Alright, here we are. We have to answer 3 questions. This is number 6 on WebAssign. Alright, so we have a study of the faculty at U.S. medical schools that revealed, alright, so 33% were women and 67 were men, right? So usually that's a sign that, alright, so this is how these people, right? So this set right here is partitioned into 2 parts. The first part is men, the second part is women. And then we have information about these men and these women, right? Which tells us that when we draw this picture, we'll have, let's say we put the women up here and the men down here, right? So that's the first part. Men and women, we've partitioned our sample space. So there's a 33% chance that is a woman, and there is a 67% chance that is a man. Okay, let's read on. Of the women, 34% were full professors or full or associate professors, 49 were assistant professors, and 17 were instructors. So that means that we need 3 branches extending out from women and from men, because we usually get the same information about both. So we'll do 3 and 3. So I'm going to say FA is going to be for full and associate. I'm going to use A for assistant, and I'm going to use an I for instructor. So same thing down here, FA, A, and I, right? So of course in the previous example when I was talking about Bayes theorem, I only had 2 branches. it was a set and its complements, you can have as many branches as you want. In this case, we happen to have 3 options for these positions for faculty members, so we have 3 branches. Okay, so now we're gonna put 34% here for full associate, 49% here for assistants, and 17 for instructors. That's for women. And then for the men, we have 54 for full associate. We have 38% for assistant, and then we have 8% for instructors. Okay, so we have our tree diagram. That's all the information that we have. All right, so let's answer the questions. Part A, the probability, so we want to find P, that a faculty member selected at random held the rank of instructor. So you want to find the probability of I, since we're using I for the event that the person is an instructor. Okay, so remember, this is the part where we chase down the branches that lead us to I, right? So you go this way and then that way, or you go that way and then that way, right? So the idea is, if you want to find the probability that someone is an instructor, you have to add the probability that they are an instructor and a woman, and to it you will add the probability that they're an instructor and a man, right? And these will be mutually exclusive events, so we can add the probabilities this way, and that will be equal to, so remember, along the branches you multiply, and then when you jump from one branch to another you add, right? So in our case that's going to be 0.33 times 0.17 plus 0.67 times 0.08. And then once you do that, that number turns out to be 0.1097. So since we're trying to round to 2 decimal places, we'll say this is approximately 0.11. So here it is. So there's about an 11% chance that a person selected at random is an instructor. Okay, part B. What is the probability that a faculty member selected at random did not hold the rank of instructor? All right, so notice the difference here. Did not hold the rank of instructor. So this means that we're just really trying to find the probability of instructor complement, right? The probability of I complements. So if you remember, the probability of I complement is just 1 minus the probability of I. So that would just be equal to 1 minus 0.1097, which is approximately equal to 0.8903. Right, and then of course you can say that this is equal to, if you're rounding to 2 decimal places, 0.89. And I guess maybe here, I'm not sure if this is approximately or if this is an exact answer, but anyway, so this is what you would enter if you're rounding off to 2 decimal places, in this case down here. Alright, so then of course you can say, alright, so could I have found this answer by just finding the probabilities that someone is not an instructor, meaning can I find the probability that someone is a full or associate professor and add to it the probability that someone is an assistant professor, and would I get the same answer? And the answer is yes. So what I mean, and I'm not gonna do this, I'm just gonna show you. So if you thought, all right, not an instructor means either, full or associate or assistant, and you could have done this. You could have chased down these branches. You could have done down this way and that way, then this way and that way, then this, or this. And if you had multiplied along the branches and then added when you jump from one branch to another, you would get exactly the same answer. But notice that it's much easier to think about this in terms of complements than it is in terms of adding up the different probabilities. So this is what I would recommend doing here in part B. Okay, and then finally, part C, which is really the more challenging one, we'll do that over here. So let me take the time to erase what we've done along these parts. And I'm erasing probably too much, but that's okay. Alright, so let's just try to redraw parts of this diagram again. Okay, so we had women here, men here. Alright, so let's see what the percentages were. 33 and then 34. And then for instructor for women, we had 17. And I think we got everything. Okay, so now part C. So if a faculty member selected at random held the rank full associate professor, what is the probability that the faculty member was a woman? So this is a case of you have to figure out, okay, so I see full associate, so that's the FA parts, and then I see woman, so that's the W. So is it probability of W given FA, or is it the probability of FA given W? So what I'm claiming is this is what the question is asking us. Probability of W given FA, right? Because another way to read this question is kind of backwards. It's saying, what is the probability that the faculty member was a woman given that that they held the rank of full associate professor, which gives us this over here. So you gotta be really careful because it's gonna really make a difference whether the W comes first or the FA comes first. You just have to read the question and make sure you know. It says what is the probability that woman, so that means that comes first. Okay, so that's what we're trying to find. So remember again from 7.5, this is the probability of woman and FA divided by the probability of FA. And then we chase down the tree again, right? So this is equal, coming down over here. All right, so probability of woman and full associate professor would be, so that's woman, and then full associate right there. So that's going to be equal to 0.33 times 0.34 divided by, okay, so now we want to find the probability of full or associate professor. So that means I have to just look at every branch that includes those. So that means I either go along this, or then down here and here, right? So those are all the ways that I can get to full / associate professor. And remember, along the branches I multiply, skip from one branch to another I add. So that means I still want the 0. Oh, okay, let's try that again. 0.33 times 0.34 plus, jump to the next branch, 0.67 times 0.54. And that should be my answer. So when I did this, I ended up with 0.2367, or approximately 0.24 if we're looking for 2 decimal places. So the idea is, if I know that this faculty member was a full or associate professor, so given that fact, the probability that it's a woman is about 24%. Right, so if you can do this problem, and essentially it just comes down to, can you draw the tree diagram? Do you know what comes first? If you can do this, you can do every problem in 7.6, and you can do every problem on the quiz, and you should be good. So good luck on the quiz this week, and here is our password for that. So the password, all lowercase, I repeat, all lowercase, is just COND. So COND, all lowercase, short for conditional, is the password for quiz 11. Good luck.